Lost my train of thought. Oh well. Um, yeah. Well, anyway, what I'm saying is there must be a center. There must be a center to the universe. In other words, somehow we could like Tung. If anybody knows about the Tunguska situation, they thought it was a large, like asteroid or a meteor out in Siberia that exploded, I think 1908, but they couldn't get there until 1921 or something like that. And they could see the trees all falling down, and there was a, they could tell, going back, they could tell there was a, you know, basically where it exploded, whatever you want to call it, how high it was, how massive it was. So they can go back and trace a lot of this. So what I'm saying is, if you had a model where, you know, either a collision model or there's a mass that just exploded, however that mass got there, right, then there has to be a center to the universe, right? There has to be a center to the universe. So that's sort of what I'm getting at. Like I said, this is a little rough. Doing my best, but the, you know, it's free, so hey. Oh, the bottom here, I just took a, I keep telling people this. You must accept the truth from whatever source it comes. You must accept the truth from whatever source it comes. Good lines to live by. Unfortunately, a lot of people in the scientific community don't want to pay any attention to that. They sort of pick and choose what they're going to believe, and if it doesn't fit their ideas, then they just throw it off to the side. So, you know, you kind of either, you know, go with, like I said before, make science truthful again. You either kind of go with it or you don't, but if you don't, then just find another field of endeavor or vocation to do. So I try to keep with some of my other ideas about, like, just because you can write an equation doesn't mean it has anything to do with reality. There are plenty of equations out there that have nothing to do with reality, take into account something like time dilation and the special theory. You can put all the numbers you want in there and you'll get a number. Unfortunately, you know, as far as conceptually, it has no bearing on reality whatsoever. That's why I say, you know, the special theory, the general theory, they're interesting, you can read through them, but they have nothing to do with reality. So, let me get the third one out. And the third one gives the current view. Let me, hold on one second, let me check something. Yeah, there's a little dot there, but there's sort of the current view of our universe and my view of the universe. And if you look at it, looking at, I sort of touched on this base a number of times, but the current view is something like, you know, space-time just kind of unfolds, right? So you get this big bubble kind of situation. It's the same effect if you go on Wikipedia or YouTube. You can see like these giant thermonuclear explosions, and it's just like a one big, it looks like glass. It looks like bubble of glass just kind of exploding, right? And that's sort of the idea of what this is. I call it down here sort of a nuclear explosion, right? So it's like that. It's expanding, or a balloon, right? So what they have, what they talk about is matter is on sort of the membrane of the balloon, or the membrane of this explosion, right? So matter is all these dots here that are all over the place. There's nothing inside, and what's on the outside? What did it explode into? If you say nothing, that's just space, and that doesn't work. So that's, I think, just definitely a bad idea, right? The other thing is it's self-consuming. I mean, when you had that nuclear explosion to go off, right, there's nothing left. I mean, it actually works by just creating, well, obviously a lot of radiation, but just this huge concussion that goes out with it, right? It goes out, and it creates a vacuum, and then it all comes back in again and creates this big mushroom cloud, right? But there's no matter left. It consumes everything, like the bomb at Hiroshima. You're not going to find a little piece of the, you know, was it Little Boy or something? I don't remember which one was. No, that was, yeah, Little Boy was Hiroshima, I think. Fat Man was Nagasaki. You're not going to go find a little piece of metal that was part of the bomb at Hiroshima, right? It's self-consuming, and that's what this is too. There would be nothing left anyway, right? It needs a membrane. If this is what's happening, like a balloon, nothing inside. What's on the outside, nobody knows, right? Doesn't work. So objects are on a membrane. Shape is kind of unknown. It looks like like I said, a nuclear explosion just kind of going out. So what's my view? My view is basically what I said before. Space is pre-existing. In other words, it started off with nothingness. We don't know if we're the only universe. I mean, I agree with that. We can speculate quite a bit as to what's going on over there or outside in our universe. We don't know. But again, Occam's razor, start with the most simple. The most simple is that space was pre-existing. Somehow there was a mass, maybe a large mass, that exploded, creating the cosmic background, microwave background radiation. So, I mean, that's possible, but if it did, I mean, everything would be flying apart, right? And that's what we see. We see no matter where we are, even with this one, the current view, but even with this one, we can see everything's just moving away from each other. Everything's just moving away. So I can account for all what the matter is in the universe, and it's not in a membrane. It's just like a regular pipe bomb going off, or perhaps a firework going off, except it's in space, so it's slightly different, right? So I say, there is a center to the universe there. Objects radiate out. Flat space, Newtonian space, right? We don't have curved space or curved this or warp this. There isn't. It's what it looks like, right? Yes, a geographical center. I don't know. That's why I came up with the colossal collision. Rather than saying there was just a blob and it just exploded, with inflation and all the rest of it. What happens if there was actually a collision between objects that did it? I'm not sure if that really solves it. It's a possibility, except for the fact that now instead of just, you have to account for one blob, you have to account for two blobs. And I'm not sure that really solves anything either. But yeah, non-nuclear explosion. In other words, when this thing explodes, like a hand grenade, right, there's mass all over the place. Or a fireworks, right? What's going on the outside of the universe, like what Hubble found, exactly what Hubble found. What's farther away from us is moving faster. What's closer to us is moving less fast. That's exactly what he found. And that's exactly what, like a fireworks will do. Some go out, the first go out the farthest, the fastest, and as you go back to where the explosion actually occurred, I mean, a few just got out, but it wasn't very fast. It just sort of plopped out. Right? So you can account for the expanding of the overall firework, and by the way, it's not accelerating. So it doesn't accelerate forever. Some people think that the universe is expanding, or what we see is expanding, but accelerating. They think that the universe is accelerating, but it's not accelerating, and it's easy to demonstrate that because I have a video that says the expanding, not accelerating universe. Right? It's easy. You can go look. I think 25 minutes. Pretty simple. So no nuclear explosion. This leaves matter. That does not leave matter. This leaves matter. I can account for that. Right? I don't need inflation theory. I don't need a lot of the baggage that goes with that kind of. Very simple. Right? Start flat space, explosion into that space. There has to be a center. All right. So that's what I'm. Let's see if I can bring up my. What do I need? Yes. See time for. Oh yeah. If you want to look at time, I have another video. Time's up for space time. In other words, time doesn't exist You can't meld together time and space. It has nothing to do with each other. It's not possible, right? So I talked about that. Yeah, space, matter, time are all independent of each other. Time, because it doesn't work. So I think I kind of, in a very rough way, or raw way, I could call this raw science. The bottom says if universe is isotropic, some say isotropic, I say isotropic, must have a center. In other words, if you have this, you might see sort of the same thing, no matter how you look at it. But if you have a model like this, right, we think it's basically the same no matter where we look, how it's falling out radially. And if it's isotropic, I mean, that's a condition that I think comes with sort of the explosion kind of theory, right? A big ball rather than a little tiny little singularity, or the collision model, right? Either one of that will give you sort of the same idea of what's happening here. It's isotropic, it's similar to wherever you look, and maybe without bounds, I don't know. So, sorry, I'm going to read, just show you what I had told you before about the appendix I wrote. And for you Einstein fans, you might have read this book. Oh, one thing I was going to, sorry. Let me just change something for a second here. Right? I think there's a center. Just like, go back, you can trace the explosion with the little boy on Hiroshima, how high it exploded, where it actually exploded, how much you could see by the devastation. You can sort of trace it back. And the same thing what I was getting at with the Tunguska situation, explosion. I mean, they can basically trace back within reason, all the parameters that set that up. And I think you can do that too, or someday people might be able to find the center of the universe. I mean, if sort of like two parts are flying away from each other, that would show a lot faster than just, two pieces. Think about a firework, I guess. I mean, they're flying out faster. But if you look on the other side, 180 degrees around the other side, then the two are flying faster and faster away from each other than two in the same line of direction, if that makes sense. So go find the center of the universe. Okay, I'm going to read something here, and for you Einstein fans, it's actually, I don't know if you can read this. I'll try to read it or show it to you, right? Relative